Okay, so now let's do the next question. Okay, so here in this question, the one unique aspect about this question is that there is a dependent source over here. Okay, otherwise there is no other than there's nothing unusual about the circuit. Okay, except that there is a dependent source over here. So here the question is, the switch is opened at t is equal to 0. Okay, the switch is opened at t is equal to 0, which means at t is equal to 0 and after time t is equal to 0, the switch is open, which means what was the switch position before t is equal to 0? It says over here the switch is opened at t is equal to 0, which means the switch was closed before t is equal to 0. Okay, that's what this question means. The switch was closed before t is equal to 0 and at t is equal to 0 it became open. Okay, the switch is opened at t is equal to 0 after the steady state is achieved. That is, which means before t is equal to 0, the switch was in the closed position and the circuit was in the steady state condition. That is what it says. The switch is opened at t is equal to 0 after steady state is achieved, which means before t is equal to 0, the switch was closed and the circuit was in the steady state condition. Okay, and then at t is equal to 0, the switch became open. Okay, now what is the question? Find the expression of the transient current I. Yes, they are asking us to find the value of I. Here, this is what is I. This I 10I is the name of this voltage source. This is a dependent voltage source. This is a current controlled voltage source, right? Because here there is I over here. So this is a voltage source in which there is a current. This is 10I. And what is I? I is the current through this branch. Okay. So your job is to find the value of this I, or your job is to find the value of the current through this branch. That's the question. Okay. So let's do this question. So here, like I said, we have this is the most important sentence, right? In every question, you need to find out when is the steady state condition or what is the value of the initial condition. If the value of the initial condition is not given, then you have to know when the circuit is in the steady state condition. Okay, and only when the circuit is in the steady state condition only you can then find the initial value of the elements, initial value of the initial current across the inductor and the initial voltage of the capacitor. Here there is no capacitor, only inductors here, which means you need to find the initial value of the you need to find the initial current of the inductor. To find the initial current of the inductor, then you have to know when is the steady state condition is achieved. And here it is written that the switch is opened at t is equal to 0 after the steady state condition is achieved, which means before t is equal to 0, the circuit was in the steady state condition. So we need to draw that circuit. That is at t is equal to 0 minus. Okay, this means that just before t is equal to 0. Okay, I will just write the full explanation so that you will understand it. The switch is closed and the circuit is in steady state condition. What is the meaning of steady state condition? All you have to understand that the meaning of the word steady state condition means the inductor becomes short circuit and the capacitor becomes open circuit. That's all. Okay, that's what it means. You're doing this because you need to find the current through the inductor if there is an inductor, and you're doing this to find the voltage across the capacitor if there is any capacitor. So here there is no capacitor or inductor here, which means you need to find the current through the inductor. That's why we are doing this part of the problem. Okay, this part is being used to find the initial value of the initial current or voltage across the elements. So here the switch is closed, right? So let me draw if the switch is closed, then this 50 volt is connected to the circuit, right? So that means the switch is closed. Okay, the switch is closed. This is 50 volt. Okay, here you have the resistor 30 ohms. Okay, here you have the dependent voltage source over here, plus minus. The value over here is 10I. Okay, 10I, and this branch you have a resistor over here and you have the inductor, but the inductor is in a steady state condition, the inductor is shorted, right? the inductor is short. Just draw like this, okay, just so that you will understand. I just put this two dots over here just to understand there was an inductor, but now it is being shorted. This is 20 ohm and this is current I, the same I over here, and what your job is to find the current through the inductor, right? The initial current. We call this as IL of 0, right? Because if you check the Laplace transform of the, you need to understand why we are doing this, right? If you check the Laplace transform of the inductor, or the transformed impedance of an inductor is an inductor with a negative voltage. This is the Laplace transform of an inductor, in which the value of this impedance is Ls and the value of this voltage is Li of 0. So you are trying to find this value. That is why we are doing this. That is this value. We are trying to find this value. Okay, that is why. Okay. So here one interesting thing about here is that, see, we will use Kirchhoff's voltage law. We will use mesh analysis. So in that case, let this be I1, let this be I2. So in that case, you can see for yourself that the name of this, the current through this branch is I. The current through this branch is also called as I2, and also the current through this branch is also IL of 0, which is the current through the inductor, which means the current through this inductor, the current through this branch, and I2, all these three are the same current itself, which means I2 is equal to I is equal to the current through the inductor, or the initial current across the inductor. All of them are having the same value, so it becomes very easy, you know. So in that case, let's do this question applying the equation to mesh 1. Okay, let me write that. Applying KVL to mesh 1, what do you get? We get the equation as 30I1, okay, let me see, minus 30I2 is equal to, here this I1 is this 50 volt is, this I1 is coming out of the positive terminal, which means it is plus 50, and this I1 is going into the positive terminal, which means this positive terminal is not generating current, it is opposing current, so it is minus 10I, but I is equal to I2, so therefore I can say that this is 50 minus 10I2. Okay, very easy. So if I put this over here, this becomes minus 30 plus 10. Minus 30 plus 10 is minus 20. So we have over here as 30I1 minus 20I2 is equal to 50. Okay, or in other words, I can say that 3I1 minus 2I2 is equal to 5. Okay, this is the equation for mesh 1. Now applying KVL to mesh 2. Okay, mesh 2. So here we have, according to mesh 2, I1 is negative and I2 is positive, so that means minus 30I1, because in the mesh 2 I1 is touching only this resistor, right? So it's minus 30I1 plus, and what about I2? I2 is touching this resistor and this resistor, there's nothing else, right? So 30 plus 20 is 50. So 50I2 is equal to, what about the voltage source? This I2 is going like this, right? So it means in this branch it is going from bottom to top, which means this positive, this current I2 is coming out of the positive terminal, or this positive terminal is generating I2, which means it is plus 10I. Okay, but I is equal to I2, so therefore this is equal to 10I2. Okay, 10I2, this is equal to 10I2, so which means I can say that 50 minus 10 is 40, so you have minus 30I1 plus 40I2 is equal to 0. Okay, or in other words, we have minus 3I1 plus 4I2 is equal to 0. Okay, what are you supposed to find? Why are you doing this? You are doing this because you want to find the current through the inductor. You are doing this because you need to find the initial current through the inductor, which is IL of 0. We are trying to find this value. That is why we are doing all this. Okay, so if you want to find this, you just need to find the value of I2. Just simply find the value of I2 only. Okay, that is why you are doing all this. You are doing this condition. You are applying the steady state condition to find the value of the initial current. Only if you find the initial current only, I can substitute that value over here. Then only I can apply the Laplace transform of this inductor. That's why we are doing all this. Okay, so I just need to find the value of I2. So what is I2 over here? I can find the I2 by first substituting the equation for I1 over here, right? So in that case, I can say that, let me see, 3i1 is equal to 4i2, or in other words I can say that i1 is equal to 4 by 3i2. Okay, so I can substitute this over here, this equation. So in that case this will become, like I said, 3i1, or what's the equation? 3i1 minus 2i2 is equal to 5, minus 2i2 is equal to 5. So this will now will become 3 into, and what is i1? i1 is 4 by 3i2. 4 by 3i2 minus 2i2 is equal to 5. 3 and 3 will cancel each other. We have 4i2 minus 2i2. 4i2 minus 2i2 is 2i2 is equal to 5. Therefore, i2 is equal to 5 by 2, which is equal to 2.5 amperes. Therefore, the initial current through the inductor is nothing but 2.5 amperes. Okay, this is what you are trying to find, and now you found it. Okay, now I can, so now this was at time when time t is equal to 0, or you can say, or you can either write like this or you can write like this, at time before 0. Okay, at time t less than 0 or before 0. That's what this means. Now at time is equal to, at time t is equal to 0 plus, which means at time just after t is equal to 0, or you can either write at time t after 0, greater than or equal to 0. Okay, then according to this question, the switch is opened at time t is equal to 0, right? So therefore then the switch is open. Very easy, right? So open means, what does it mean? Open means this circuit will be open, which means this part of the circuit becomes open, which means no current will flow through this branch. So which means you can remove this branch completely. So only these two elements remain, right? That's all. Very easy. So therefore the circuit will become like this. That is, we have a resistor over here, then you have a voltage source over here. Okay, what is the value of the resistor? 30 ohm, 10i, 30 ohm, 10i, and here you have a resistor, and then you have an inductor. Okay, the value of the resistor is 20 ohm, and the value of inductor is 2h. So 20 ohm, 2h. Okay, this is at t is equal to 0 when the switch is open. So that's why, if it is open in this part of the circuit, that's why I said, when depending on the position of the switch, there are two circuits in this given circuit. One is when the switch is closed, the other is the switch is open. So when the switch is closed, this is the circuit. When the switch is open, this is the circuit. And this is the value of I. So now your job is to find the value of I. And you can now find the value of I by applying Laplace transform to this circuit. Okay, you're going to apply Laplace transform to the circuit, or the transformed impedance. The transformed impedance of the circuit. So you get is this, what is the Laplace transform of 30? It is 30 ohms is 30 ohms itself. A resistor, the Laplace transform of a resistor is the resistor itself. Okay, what about the Laplace transform of 10i? The Laplace transform of 10i is 10 I of s. Okay, because where I of s is the Laplace transform of I. So therefore the Laplace transform of 10i is 10 I of s. Okay, then we have this, the Laplace transform of the resistor is resistor itself, 20 ohm, and here there is the current I of s, which is the current which is the current you need to find, right? According to this question, right? According to the question, you are supposed to find the value of current I. So you need to find the Laplace, you need to find the value of I of s, and then you need to take the inverse. And what is the Laplace transform of the inductor? The Laplace transform inductor is given by an impedance with a negative voltage. Okay, and what is the value of the impedance? It is supposed to be Ls, right? Ls is the value of the impedance. But what is the value of L? The value of L is 2H, 2 Henry. The value of H is 2 Henry. So this will become 2S. The value of L is 2, so therefore this is 2S. So the value of this impedance is 2S. Okay, and what about this voltage over here? What is the value of the voltage? we know that the value of the voltage is L into IL of 0. Okay, L into IL of 0. What is the value of L? 2. And what is the value of IL of 0? We already found out it is 2.5. So 2.5. So 2 into 2.5 is 5. Which means the value of this voltage over here is 5. This is the transformed impedance of this circuit. Okay, and here your job is to find the value of this I of s. After finding the value of I of s, you simply take its inverse. Okay, so let's do this. So we know the current through here is I of s, right? The current over here is I of s. We already know that because it's already written over here, right? So in that case, let me write the equation. We have the equation as I of s into, let's see what we have here, 30 plus 20 plus 2s. We have 30 plus 20 plus 2s. Okay, only that much elements are there. 1 2 3, only 3 elements are there. 30 plus 20 plus 2s. Okay, is equal to, what about the voltage source? If you look at the voltage source, this I of s is coming out of the positive terminal. It's going from top to bottom, it's going downwards. So therefore this is coming out of the positive terminal of this battery. So which means it is plus 5. Okay, and what about over here? This current, this I of s current is going out of this, going from it is going from bottom to top, right? It's going upwards, which means it is coming out of the positive terminal. Therefore this voltage source is also positive. So it is plus 10 I of s. Plus 10 I of s. Okay, this is the question. So here you have I of s into, what is 30 plus 20 is 50 plus 2s. Okay, is equal to 5 plus 10 I of s. Okay, so if I bring this 10 I of s in over here, it will become minus 10, right? Minus 10 I of s. So for this 50 minus 10 is 40. So you have I of s is equal to 40 plus 2s is equal to 5. Okay, this is the equation. So in that case, I can now say that I of s is equal to 5 by 2s plus 40. Okay, but now you need to make this equation into a Laplace transform formula which you can understand, which means I need to take 2 common. So this will become 5 by 2 into s plus 20. Okay, and what is 5 by 2 is 2.5. So that means I can write like this. Okay, that is 2.5 by s plus 20. Okay, this is the value of I of s. So therefore I, or I of t, or I is nothing but the Laplace inverse of this, which is nothing but 2.5 into the Laplace inverse of 1 by s plus 20. 2.5 into Laplace inverse of 1 by s plus 20, which is nothing but 2.5 into, and what is the Laplace inverse of this? Is nothing but e raised to minus 20t into u of t. This is the value of the current. Okay, this is how we do this problem. Very straightforward. This is only difference is that there is a dependent source. That's all. Even if there is a dependent source also, it doesn't matter. You are doing this problem exactly like the way how it was supposed to do. Okay, there's no change in that. That's because there's a dependent source. There's not much change in that. Okay, so this is how we do the problem. So as usual, first what you do is reading the question, you understand when is the steady state condition is, and from that condition you find the initial value of the current of the inductor or the initial voltage of the capacitor, whatever the circuit is. Okay, you find it. If there's an inductor in a steady state condition, if you see an inductor, you just simply need to short it. If you say a capacitor, you should open it, and then you find the corresponding value. Either it should be the voltage, initial voltage across the capacitor, or like here the initial current across the inductor. Okay, and after finding the initial current, then you apply the circuit after t is equal to 0, and then you consider the switches, whether the switch is closed or open, that depends on the question. And then after you draw the circuit, and then you apply the Laplace transform to the circuit, and then in the Laplace transform circuit, wherever you see this initial value of the initial current of the inductor or initial voltage of the capacitor, substitute that equation over here, and then after that you find the equation of the corresponding parameter whichever you're trying to find, and then you find the inverse of it using partial fraction method. Okay, this is how we do this problem.